journey. What is Marvis? What's the state of Marvis today? What are we adding net new to it? And how are we bringing some of the wired integration into it, right? So without further ado, let's go into this, right? I'm going to spend a very short couple of 2 minutes on what is the state of Marvis. So for some of the new delegates and anybody tuning in that's brand new to MIST, Marvis is our AI engine. It's our natural language processing engine. Basically, you can ask natural language questions, saying, what's wrong with the site, what's wrong with a device. And essentially, the goal is Marvis is able to answer the question as if a human would, right? Would we get all of it right? Clearly, we showed you we're not there yet, but we've been on that path, on a war path to get it right and get some of the data flowing, right? So this becomes where the help desk, if somebody calls in and says, hey, what's wrong with that particular site, right? We can actually ask Marvis the question, and Marvis say, hey, RF looks okay, APs look okay, DHCP looks okay. Essentially, the user now has to, we're focusing the user on where do you need to go troubleshoot if something is amiss at that site, right? So here it's saying, authorizations, whether that's PSK or Radius, is having an issue, and you can now go look into sort of the FBI case file we've built for this, right? So we have all the data. The point is not more data. The point is getting the answer right? But we do show the data because we run into IT engineers who are like, well, prove it to me that you've actually made the correct decision here, right? And so we actually have all the data. We take you through a full journey. In fact, one of the things I'm going to show you is how does this correlate? Are all the clients suffering? Is only a particular client suffering, right? So this is the type of data that Marvis already has and has been running in production networks for a while. Here's another example. One of the most common tickets that you get into help desk is, why is an individual user having an issue? We spent 9 months trying to understand, hey, is Abhi's phone having an issue because he's a victim of a systemic issue, or is it specific to him? 9 months, multiple algorithms. Now with high veracity and efficacy, we're able to say that device is having a very specific issue.
Sudheer,
yeah.
I have a quick question. And this may be some to Bob as well. So Bob, on a recent podcast, you said that your accuracy rate of Marvis now with the change in algorithms was roughly 50%, which I believe is about 20 to 30% better than some comments from maybe a past WLPC. With the ultimate goal being as high accuracy as possible, what changes underneath the hood are allowing you to gain that higher efficacy rate and accuracy rate among Marvis? Because Sudheer's saying it's not the data, but you're saying it is.
Well, it starts with data. You have to have the right data to answer a question. So if you look at how we're actually improving the efficacy of Marvis, how we move from 20, 30% to 50%, or last year, a good part of that was data, getting the right data we needed out of the AP, right? Okay. So we got some improvement from doing that. Now you're stealing the thunder from a little bit, another slide here. We will go over to what else have we added under the hood.
I'm sorry, I didn't say it's not the data. What I mean is, we shouldn't throw data at network engineers. Of course, network engineers revel in it. But if there is a zoology major and a night shift is a help desk guy at a university, he doesn't care about all of this data. And do you just automatically, when you hear wireless, automatically escalate it, or can you do any little bit of triaging, right? If an AP was unhealthy, we'd find that out, right? So so data is truly fundamental to how we are improving the efficacy. And again, this is all the current state of where it's headed, right? So now this next question is super interesting, and I'm going to actually pause once we go through this, right? So the next question is around, how do we become proactive with this? Some of you run a large sort of public institution or hospitality venue or whatever, and you're not necessarily seeking people out and trying to understand what's going on with their network. But for enterprises, we've had a customer that essentially, on average, used to get about 100 user-open support tickets, meaning one of the employees walked up they have something called a tech lounge, to a tech lounge, and said, hey, my Wi-Fi, something's if something's wrong with it, right? So 100 user open support tickets before missed. They were valid. They were measuring this for a while. The CIO edict was, I want that to be 0. I do not want any single user to be able to go have to go to a tech lounge and say my Wi-Fi sucks, right? So he said, Mist, if you're so hot shot and you're walk on water, we're going to give you a building. And we're going to ask you to go challenge and take my user open support tickets to next to nothing, right? So they gave us a building, actually saw improvement, and then we went replaced that entire network, 20 countries we replaced, and now they're running Mist. Long story short, 11 months later, they had measured in the month of January 2019, they went from 100 on average per month to 2 for the entire month. They have 20,000 users connecting every day, right? So we didn't get to 0, but how did they get there, right? So first we solved a bunch of, miscellaneous problems, DHCP issues, radius issues, blah, blah, blah. And then they turned their attention to this particular command on Marvis and say, now, some of these guys are not opening support tickets, but I want to go find that out. Who are these guys having a bad Wi-Fi experience? So they basically asked this question, unhappy users at a site, and literally they sought people that are having a bad Wi-Fi experience and were not complaining and got them remediated, got them to a better place, right? And we've actually, in the recent past, we've added another command here saying, essentially, show me slow Wi-Fi users. It's one thing to say users are not able to connect because credentials or passwords or God forbid, captive portal, but it's a whole another thing to say who's having a slow Wi-Fi experience. So now we've actually basically said, show me slow wireless users at any given site. This works globally for all our customers, and it will be as snappy as you saw it here. Is essentially this is saying Jody's iPhone's having a slow Wi-Fi day. Every user, every minute, we are predicting what their throughput could be that particular minute, whether they're transmitting packets or not, whether they're using the network or not. That estimation tells us who's having a slow Wi-Fi day, right? So this is actually just the current state of the art for us as Marvis stands. Yes?
So looking at both this and then other competing systems I've looked at for the analytics, one thing I always struggle with is like the weak signal. Let's say that 50% of the time that weak signal that you had up is somebody just leaving the network. The signal gets weaker and weaker because they have business, 2 blocks away, they're getting coffee, they're going to lunch. At the same time, all of the data is being gathered.
Yeah.
Are these, sort of outlying things that really aren't problems? Are they somehow compensated for?
Absolutely. Actually, you use the right word, Lee, which is outlying, right? So the power of learning with data over 4 years is actually exactly that, is you learn what are outliers. You learn when people are walking in, when people are leaving out, where things don't matter. And so our users have truly come to. I'll give you an example. We had a large service provider. We're deploying about a 2,500, 3,000 AP co-located large campus, right? And so they initially said, their design said, 22 APs. We said, no, we think it's actually more like 27, 29 APs on a particular floor. And we said, nope, that's where our drops are. That's where you're going to deploy. We deployed. Immediately, our coverage SLE was showing, these particular APs are constantly serving RSSIs that are worse than neg 70, neg 75 throughout the day. And as that started to go, we were able to, in fact, one of the things you'll see in our SLEs is you can actually, in the coverage SLE, you're able to see exactly which AP, where in the network is this coverage bad, which particular AP is serving, negative bad coverage, right? So we're able to pinpoint to that. And so, absolutely, we take care of the outliers, we eliminate the outliers, and we're learning constantly.
Well, put another way, I'm sorry, Bob, put another way, when you've got that red bar of weak, are you saying the situations I'm describing, the person who leaves couple times a day, leaves the environment, signal gets weaker and weaker and weaker, and then they come back and it gets stronger and stronger. Are you saying that red bar does not
Does
reflect
not
any
include.
of that?
Absolutely does not.
That red bar is what we call mutual information, and that's trying to help us figure out if something is causing a problem like a network feature. We will talk about anomaly detection here, and that is what's starting to help us start to figure out whether or not that is a normal behavior or baseline behavior.
Absolutely, red bar does not include outliers.
Very good.
for sure.
Are
Thank
you
you.
learning per customer? So, like, is there some sort of ability to focus in on your customer and say, hey, you're a university customer, you're probably going to have a lot of transient users?
So we have a slide, so that's going to be the anomaly detection section. We're going to talk
Okay.
about the power.
So Scott, you're jumping here. So no, but okay. So it's good. So let's actually quickly.
Can I ask a question that I think would not be an anomaly detection question, which kind of gets to the root of, I think, what you're asking, I'm curious about, which is how do you know that what we're seeing that looks like it's bad is actually impacting the user, whatever that is?
Yeah. So actually, good point. So how do we know a user is having a slow Wi-Fi day, right? So throughput or an estimation of somebody's current usable throughput experience, right? So what we do, we are on, even for that, we are on our third version of the algorithm. So what it is there's fundamentally 4 factors. Let's say, number one, let's say I want to deliver 100 megabits to a user. Number one, the device has to be capable, right? If it's 11B device, not going to do 100 megabits, right? So we know during association what the device capabilities are. Number two, its current coverage pattern, right? Meaning, what is its RSSI and what is the transmit MCH rates we are using for it, right? We know both uplink and downlink because we're rate fallbacking and arriving at an MCS rate. The device is transmitting RSSI, so coverage matters. So if you're in a steel cage, around the corner from the AP, your coverage is going to be low. That impacts throughput. Number three, let's say I have a brand new MacBook Pro, I'm sitting right under an AP. Will I get 100 megabits? The ambient capacity matters, right? So we know we have a dedicated third radio at all times watching the network. That dedicated third radio gives it ambient capacity down to a very, very granular level. So we fuse that. So first, device capability. Second, coverage of the device, of that individual device. Third, the capacity of the ambient network. Now let's say I have a brand new MacBook Pro, I'm sitting right under an AP, and the channel is wide open and clear. Will I get 100 megabits? Well, the rest of the network matters. The wired network matters. So we take every user, every minute, we fuse those 4 things and use a decision tree algorithm to come up with what do we estimate is the throughput we're going to deliver to that device. That's what that bar is. It's not purely RSSI.
Yeah, and so this is getting to the theme of when you look under the hood of Marvis, you will find multiple algorithms trying to answer these questions, right? So there's mutual information trying to associate user problems with network features. There's a decision tree algorithm that's trying to do post-connection throughput analysis, trying to figure out what is your possible throughput, because we know the wireless link, we know the WAN link, we know the LAN link, and so there's a model in there trying to predict that, and if it goes low, we can kind of look at the model and say, why is it low? And then we have this anomaly detection algorithm that's really starting to give us the anomalous behavior that we're being able to correlate. And so this is where all these algorithms are coming together to give us better root causes with better granularity and better confidence now.
Awesome. You may lose your bet on location, Bob, so we may not get there. So
Let me tell you how location. Right now.
So the next thing, this is obviously super exciting for us. Obviously, we're in the Juniper building. We're so proud to be part of the Juniper family. I think there's a lot more we can do. The layman's view of the Mist Juniper merger and acquisition will feel like, hey, Juniper had a wireless size hole and Mist fits that, right? That's actually just only half the story. The real value that Mist is bringing to the Juniper family is this AI engine across the board. This is truly the very early renditions of Marvis getting wired visibility. So what you're seeing here is actually us on any switch. We know a lot of environments we go into, the switches could be Juniper, could be Cisco, whatever else, right? So it could be any of these things. We're starting to bring wired visibility into the network, right? So the switches tab is now live. You're actually starting to see. So we took a few metrics, right? We said, one of our customers, the guy that's doing 50,000 APs with us, they have a rule that at no individual switch, they want more than 12 APs, right? They just want to be able to say the blast radius, if a switch reboots or something happens to them, they want to limit to a certain blast radius. Today, what they do is they manually, go into every switch, run a script, and say, hey, is this the switch running more than 12 APs? Is it violating my switch AP affinity? Now we can actually say, no, wait, time's out. We know where all we're connected. We're actually able to say which switches are these things connected to. And so the switch AP affinity for us, we could set that number and say, monitor that. And if that ever gets violated, let me know. So now suddenly across 55,000 APs, all they have to do is just come to the dashboard and say, are there any switches that are violating my metric? Quite simple. Yes.
Okay, so I have to ask. Is Marvis seen as something that's going to eventually be standalone? I have an existing environment, switches and APs. I want Marvis. Is that going to happen?
Bob, you want to answer that?
I would say, this is what I talked about before. I think what customers are going to start to expect, whether it's Marvis or AI/ML, they're going to expect their infrastructure vendor to start to help them take care of the end-to-end user experience. So when you look at the kind of the architecture, right? Yes, there will be an AI/ML layer on top of some modern cloud stack, ingesting data from network elements, whether they're Mist elements or whatever elements, right? And so that is probably the paradigm shift that we're in the middle of seeing right now. So I think
Answer the question, Congressman.
So
the
actually,
answer is yes. Marvis will support both Juniper Mist equipment and third-party switches and routers.
yeah.
Which protocol do you use to
Yeah,
communicate
so good question, right? So you're wondering, how come, right? And we're not even talking to the switches on this. So this is actually, turns out there is a top secret protocol called LLDP that we all have to use. And so LLDP happens to have a bunch of very interesting data that you can turn into metrics. So we can, are there APs drawing too much power? Are there VLANs that are missing on the wired network that are, essentially hurting a user's experience? And we're going to talk a little bit more about that. Turns out LLDP actually has the switch version in it. So now voila, with just a sprinkling of Mist dust on their Cisco wired network with Mist APs, we're able to tell them across their entire 1,000 stores retail deployment if there are any switches. And you don't have to configure what your version is. We will learn the version, and we'd say, hey, these are the two outlying switches that are actually not the same version as the rest of your network.
Now, in that case, are there Marvis licenses for the non-Juniper switches?
No, this is all part of our Marvis subscription. Yeah, so Marvis there is no additional, you don't pay by switch in this case, right? Yes.
Are there plans to take this to the next level with SNMP, maybe webhook, streaming telemetry kind of stuff?
Yeah, all of that. Yeah, so one thing Bob will say, two things he will never build. He will never build a controller again, and he will never put SNMP on anything. However, we're using netconf. We're fully open config ready. Mist actually has and Jake's done a class around this. Mist has a open config consumption API and open config northbound API as well. So we're using netconf downstream, OpenConfig downstream, and OpenConfig upstream. We use webhooks to stream all of this.
And just to clarify, Sudheer, I will not build an embedded software architecture. That is the home of bugs, right? And so distributed cloud software is a much better way to maintain and develop software on.
Right. So where this thing is headed, there's a bunch of other very interesting things we can do with this, right? So this is, again, without even talking to the switch yet, one of the things that we ask installers to do is, hey, I'm going to salt and pepper my APs across multiple switches. Now it's a simple view to say, has the installer done that? Right? I was actually looking through a couple of our customers, and I found, some of our customers it looks really good, salt and pepper. Some of them think they did salt and pepper, and this thing is showing, no, you actually did not. They just happened to put, the APs to the same switch. So there's all kinds of interesting stuff we can do. This is all manual now. You can actually go in and see, which APs are being served into what locations by what switch. Imagine you can actually take this to the next level and say, where do I have wired redundancy and wireless redundancy. Wireless redundancy is if an AP goes down, another AP helps me with it. But what if both those APs are connected to the same switch? We're going to actually start to point out wired and Wi-Fi redundancy, yes.
So could you detect that you connected an AP to a port that's configured at 100 meg, for instance? And
Ooh,
the
yes,
system will
absolutely.
do automatically.
Absolutely. So you'll see that. We have done about a 2,200 site deployment in which for that particular customer, unbeknownst to them, turns out about maybe 50 or so sites, the switches were at 10,100, right? And we're like, whew. 10,100, did you intend? I was like, no, that's not intent. Wrong config, push config. Now, in the Juniper world, we could actually push config. I mean, so the notion of where do you get to with self-driving, that's the point. How do you get to self-driving? Self-driving, you can only get to when the efficacy of your actions are super high confident, right? You have 99% confident that this action is spot on, is right, then you can actually go take the action.
So it's changing the speed of a port like 100%?
Yeah, I mean, it's pretty black and white, right? It's not very complicated. Absolutely. Yes, sir.
Is the AI from the wired side also feeding into the wireless side when it's coming up with those client errors?
I'm sorry, say that again?
So you had the client throughput before.
Oh,
the
yes,
wireless
yes,
side.
yes, yes.
Is the wired side also being taken into account for
Yeah.
things like that, VLANs? et cetera?
Absolutely. So I'll give you a couple of examples, right? So, being a cloud system, our APs are always talking to the cloud, right? So we always know what the wired side looks like from a round trip time and latency and jitter perspective. 100% of that goes back into the throughput algorithm I was talking about. Yes, that is how we
Sorry,
determine.
I was more talking about also like
These errors?
these errors.
Oh, yeah. I'm going to show you how we take, VLANs into it as well. Yes.
Did I hear correctly that you're taking corrective actions? You can take corrective actions from Marvis?
So that is the vision. I'm going to talk about what corrective actions we're already taking and what we could as we integrate with Juniper. But I will identify what we're doing right now, which is all intrinsic to our system. So there are ultimately three types of actions, right? Actions that are intrinsic to our system. The old world was RRM, change channel, change power. We don't ask you, we just change it because we think that's the best decision for you. The new world is, I'm monitoring the AP's health. Lee's pet peeve was software bugs and hardware bugs and stuff like that. And so we know we could actually restart the process. Don't need to ask anybody's permission. The AP would be healthy. Clients are happy. We're already doing a bunch of that kind of stuff. I'm going to show you in the very next one of that.
And do you get to choose whichever corrective actions can be taken?
Yes.
Because
yes.
maybe to you it doesn't sound like a big deal, but maybe to me. it
Fair
does.
enough. Fair enough.
And also, this is all agnostic of vendor.
This piece, the visibility is agnostic of vendor. The actions, our corrective actions today are intrinsic to Mist and will expand to Juniper. Right, yeah. Yes.
Question from Brian Ward. Is OpenConfig ready for production yet?
OpenConfig is absolutely ready for config. OpenConfig is ready for production. It's being deployed in production by the guys that are proponents of OpenConfig.
Yes, he said.
Yes, so they are a Mist customer and they're using it extensively. Yes. All right. So. Let me quickly, we're going to do two more things, and then, because I feel like we're building up momentum to just tell us the damn answer, right? So, sorry. So Bob, let's do anomaly detection, and then we'll go into Marvis actions.
Okay, so back to the question, how do we get the answer? So there's multiple algorithms running under this thing. Anomaly detection is one of those critical answers. It's something that we've all wanted, we've all talked about it. The concept is relatively simple. Achieving it is really hard. Trying to get to predicting it, finding anomalies with 99% accuracy is not easy. Easy to say, hard to do. We've been on the journey for the last 4 years. We started the journey with something called moving average. This is kind of very simple-minded. Yes, we'll look at the average and we'll look at things that are above and below the average too much. We got about 50% accuracy. Yes, we could find some anomalies, but half of them were wrong. Then we went to something called ARIMA, which is really a fancier version of moving average, auto-regression. So we give it a little bit more tricky. Still, we only got to about 80% accuracy. Still not good enough for an IT production assessment. You cannot send the IT team on wild goose chases 20% of the time. Over the last year, we finally got to 99% accuracy using something called LSTM-RNN. And this is long-term, short-term memory, recurrent neural network. So this is deep learning networking technology. This is one of those fundamental reasons why AI is actually taking off. When you look at computer vision, self-driving cars, you'll find all this deep learning, neural networking at the heart of that. This is a good example where deep learning and neural network is affecting our industry, right? This is a case where we can actually leverage it to do something to actually help get to better root causes. So this is an algorithm that, I'll let Sudheer tell the customer story here, where we actually, for the first time this year, we actually had a customer, we found 140 anomalies in their network. Went back to him and said, are these anomalies real? And Sudheer, I think the answer was,
100% of them, yeah.
100% of them. He came back and said, yes, all those anomalies, these were kind of pre-connection anomalies. These are kind of success failures looking for connection anomalies in their sites.
How long does it take to detect an anomaly?
Anomalies get done every hour. And so this is looking back over 2 months worth of data. And so this is back to your coverage story. So this is how anomaly detection works. You're baselining a bunch of data in the past, looking for changes in behavior. Now, the real trick of making these algorithms work is you're predicting something, right? You're looking 2 months back, trying to predict the next hour. But the real trick is also predicting the range. What is the expected range of answers? So really you have a model that's predicting two things. You're predicting what I think the answer is going to be, and you're predicting the range in which the answer should be in. And that is the hard part of getting this to work. Those two predictions have to be accurate.
You mentioned going 2 months back. Say I go in, rip out vendor A, put missed APs in. How long before I'll be detecting an anomaly?
It will start working immediately. It will just get better. If you look at, if there's any weekly, what you're looking for is weekly patterns, right? If you look at the data, you'll see, Saturday and Sunday changes. So you want to get Saturday and Sunday kind of into the baseline. If there's any monthly anomalies, you want to get that into the baseline. So you get 2 months of data. Now, we don't have seasonal, right? I'm not looking at past year. For most networking events, the last year is not interesting. From a store, it may be interesting. From our point of view, right, the network's changing so much. Last year's data flow is totally different from this year. So right now, we use 2 months of data to make a prediction.
But how's the data retention? I mean, you say you don't want to go back 1 year because it might be irrelevant, but in an educational perspective, where students are coming in September, maybe you want to look back at last September to see the behavior.
Yeah, so we actually have something called analytics. For customers who actually want to look back for like retail customers, school customers, we can actually store their data longer than 2 months.
We go up to 13 months in that.
But standard is 2 months.
That's correct, yes.
All right, thank you.
Would that work if you have like, an event and you're expecting like for that specific week, you're expecting a lot of users, and then the next week it's like the event, the venue is empty. Like, would you take that into consideration in your learning process? Okay.
Yeah, I mean, this year we'll look back 2 months. If there's any patterns in that 2 month period, to your question, if we have a seasonal pattern like Christmas, we will miss that right now. But this particular algorithm is looking for pre-connection anomalies. Now, this same algorithm is going to be applied to coverage, looking for coverage anomalies. Is the person headed out the door, or is it really something going on inside of the network type of anomalies?
What are trigger points, I guess?
Yeah, so let me actually give you an example, right? So the example for this is what Bob's talking about. We have a customer, about 300 sites globally. They had a planned change control event, right? So they basically, they have Kindles and iPads and whatever in the store, and they wanted to change their PSK. It was planned. Everybody was told, hey, that's going to happen. And so what actually they did is they did it. Everybody was told, go ahead and do it. And then the next day, we were like, whoa, what are all these sites that are actually having anomalies? So a simple example is certificate rotation, right? When you change certificates, immediately the next day who has not actually taken the action, right? So those are the types of things where we're sending sort of high accuracy, high veracity actions on this.
Is the user able to input a note and say, hey, there's a change occurred here, and then it can recalculate from there?
Typically, what our customers do, we're not there, and I think to Francois' question, similar thing is like if there's a sudden event, there you put up a tent and 1,000 people just showed up that weren't there last week. Typically, they would actually say, hey, this week I'm gonna ignore my webhooks, right? Today you can't actually say stop your anomaly detection per se. Typically what they do is, hey, we know there's a planned change control. We're gonna go and look back at this 24 hours from now to see if everybody executed.
Could we schedule the event and let Marvis know that we're expecting more people between this date, and then you would take that into consideration, look at other customers that would have similar.
We could. We don't today, but we could, right? And this is again, as one of the guys on our team, Matt Barletta, says, we've candidly almost never built a feature that a customer hasn't asked us. We've been very, very customer driven in a lot of this type of stuff, right? And so yeah, absolutely. So
when you do event support, it's very common to add an AP or remove an AP, turn on, off.
Right.
So all this, I'm guessing, would impact, how Marvis sees it.
It actually today, we have very high efficacy, except for something extraordinary happening. By the way, it doesn't just spike because your users went up. That's not the point.
Yeah.
It spikes if your failures are going up. Right? If all your 1,000 users are able to happily come and connect, that becomes, we learn that and we move on and we're not alerting. It's if suddenly all 1,000 users come in and they're not able to connect to your network, absolutely it will wake you up saying your event is having a bad time.
So you're looking at the percentage of
fail. Exactly. Perfect. Yes.
What's the level of intelligence currently, and where is it going? So cyclically, if okay, you said like the last 2 months, would it know, well, Tuesdays and Thursdays, these things tend to happen. In a hospital, we're using these machinery. In a school, we have this type of burst going on. So
absolutely. It is time of day and day of week right now. So
how long of a pattern?
It remembers the 2-month pattern. So basically, it's learning for 2 months and predicting the next hour based on everything it learned at that particular site, at that particular organization, what the behavior would be. And then it'd say, hey, are the errors above? And if so, is it significantly above?
So currently, it wouldn't see a pattern that extended beyond the 2 months?
Beyond the 2 months, correct. Yes, absolutely. All right. So I think where this is headed is where we've spent 9 months, truly the last year since Mobility Field Day. I think we've spent building a brand new framework. So Bob?
Yeah, so kind of to the question, how did we go from 20, 30% up to more than 50% efficacy? Definitely the data, getting the data we need out of the AP was part of it. The other part of it is all the new models and algorithms we've added to be able to get better root causes with more granularity. What we talked about last year was really around, the first framework was around SLE metrics. This was a framework around user experience, and it was really around what we called mutual information, really trying to help figure out whether or not a user problem was associated with the device. And that answered quite a few questions, right? We had several customers, big customers, whenever they had a device problem in one of their distribution centers, we could quickly figure out that problem is associated to a Windows device around authentication, right? So this helps solve a certain level of questions. What we're adding this year is a new framework, an event timeline framework, really which lets us start to do temporal correlation across a lot of other different entities in the network, right? And this is what we call entities, right? All these things can generate events. My favorite one is what we call the Lee Badman feature. This is the AP health feature. This was built especially for Lee, right? This is basically trying to figure out, is there anything wrong with that AP?
I am waiting on a royalty check on it.
Yeah, you will, because this is for you. This is basically to the point of, hey, we actually have regression models now that, yes, I can tell you whether or not, if you're having some sort of AP problem, whether or not it's some sort of Ethernet chip hardware problem, or if it's a cable problem, right? So that is the power of these models, being able to classify and get back to better granularity. So for us, this becomes another entity in our correlation framework that can generate events. So when something goes wrong, now we can tell you whether or not it's because of an AP or a bug in the AP. And this is where we're adding log mining, right? So whenever an AP crashes, we can start correlating why it crashes. Is it a known bug that we already know about? We've talked about anomaly detection. This is another big reason why we're at 50%, why we got better, because now we got anomaly detection that we can trust. When we get an anomaly, a pre-connection anomaly, we're 99% sure it's probably real. And probably the biggest thing that you're talking about, and I think I've heard a little bit, is what we're calling our action framework, right? So this is where we're really starting to allow a human or an IT administrator start to take a root cause that has enough that he has confidence in and has enough granularity that he can turn into an action. And what Sudheer is going to be showing you shortly is we're starting to have customers, we're starting to see the very beginnings of a self-driving network where an IT administrator has enough trust and faith in Marvis where it says, Marvis, if you find a bad AP, just generate the support ticket. Don't ask me anymore, right? If you find a bad configuration or bug, just update the software, right? So this is that beginnings of the first steps we're seeing in self-driving. And I'll go back to the paradigm because I think coming out of this session, one thing I'm hoping everybody internalizes, this is the fundamental paradigm shift of what customers are going to expect from their vendors now, right? And I think, Lee, you've been on this wagon for a long time, right? Please don't ship me bugs. If you do, please take care of them. So this is back to, I'm going to help you take care of this mobile experience, and I don't care what device is in between the user and your internet. My mission is to help you figure out where is the problem, where is the root cause. Is it in the device? Is it in the AP? Is it in the LAN or the WAN?
I like where you're going. My question is, how does that blue IT admin box got smaller, which is good, but how do you train individuals to do
that? I told you to make this bigger. What are you thinking?
Well, no, that's where it needs to go. To match your vision, the IT admins have to do less. But what's the process from today where there's no self-driving? It's, yes, you can give information to an admin, but admin has to do all the work, to allowing it to automatically. That admin has to do himself, either train your system or be trained to use your system.
Well, I mean, I think, when I go back to the customer success DevOps team, that is the training, right? Right now, we're basically using Marvis and we're training Marvis, right? Every time we get the wrong answer, our customer success team goes over and spanks the data scientist and says, hey, you got the wrong answer, try again. To some extent, this is a training loop too, right? Yeah. If Marvis gets the wrong answer, he'll basically say, sorry, Marvis, you got the wrong answer, right?
So how do your current IT admin people give that training back into Marvis's AI?
So Sudheer is going to give you a demo of the actual.
It's just a segue.
Yeah. Oh, thank you.
If you haven't got the theme, it's Bob Sudheer.
So actually, I think right now, one of the things that we've done about 2.5 years ago, we have a dedicated product manager and a dedicated team whose entire job is looking at answers that Marvis did not answer correctly and or people being frustrated. We have all kinds of metrics around, people search for something and they don't like it and they go back and try to find it in the rest of the dashboard. We know that they didn't get. And every answer that went unanswered, we're actually starting to tabulate and respond. So there's a full team looking for that and building that closed loop, right? But to sort of where Bob is headed, let's actually go through what is Marvis Actions. This is sort of the new phase of Marvis. We really feel this is a game changer in our industry, and I think I think more and more vendors have to get here. Scott, it absolutely is about the data. It's not about showing all the data we have, right? I think a lot of systems have become too data happy just because they're streaming data. I think what we want to get to, if you really think about it, right? This is our cup of coffee view in the morning. We want every operations team in the world to just start here, to say, is there anything I need to do to help the network move on today, right? The first thing you do, and possibly the only thing you do. I think once you get Marvis Actions in place, you shouldn't have to go back and start to do anything else as an operations team. Let's take an example. Right? If let's say a user was walking in a certain place and they're actually saying, hey, I don't connect in Wi-Fi in this particular area. After a lot of troubleshooting, you may end up that, we didn't actually trunk the VLAN, the user VLAN to that area. So instead of saying users are failing authentication or not getting DHCP and blah, 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 this location, that, we're just going to tell you, hey, you need to go add VLAN 248 to that switch. And oh, by the way, we're going to tabulate this and basically, keep track of this. And the moment you say, I got it, I've resolved this action, I've taken care of this now. Now the system is saying, okay, the user said, I've added this VLAN on the switch for this access point. It should be good to go. Then what happens is now we let the AI hounds in to go to work, right? So now we go in and say, has the AI validated that that VLAN is now in fact remediated, is now present, right? So literally, this is where you want to come in and say, okay, I suggested a human action. You've taken the human action. Now, Marvis, go validate for me that that action is complete and AI validated, right? This is it. This is where we want networks to go. I'm going to pause there. There are a couple of questions. So, sorry, go ahead.
Aiden, go first.
Has this got any integration with things like Service Now? And
that was my question.
Yeah. So we already have an app that we actually stream a lot of these results to ServiceNow. And by the way, if you want to see how a Mist network performs, you should talk to your ServiceNow guys as well. Yeah, absolutely, we stream data to ServiceNow. They actually already start to act on some of this kind of stuff for their own internal stuff as well.
So you had that resolve feature. If you got I resolved the ticket in ServiceNow, it integrates back to the system and it validates it. And
that is the goal. That is absolutely the goal, right? Sorry, Francois.
That was the same question.
Okay.
Because when I see this from an engineer standpoint, like, you have to document it. You have to document your actions in the Mist dashboard, and then you're probably going to have to go to ServiceNow and document the ticket. So it would be nice if everything is.
We want all of these will be streamed to ServiceNow via webhooks to almost any platform, but definitely ServiceNow because they actually are using this. Yes. Jake.
So one thing I haven't seen is the feedback. So Marvis says, make this change.
Yeah.
Either it does it or I do it, but.
Yeah.
Does it actually go back and correlate? Did that actually fix the problem?
Yeah, that's what I was saying. Is this AI validation is what it's going to say is, user said, I've resolved it, but the system is going to say, am I now hearing that VLAN on that AP port? And so AI is going to go, Marvis is going to go listen and say, no, you said you replaced the Ethernet cable, but it's actually recurring. So we will mark an issue as recurring, or it's validated and closed. So users don't close the ticket, we close the ticket. Right? And so an example of sort of where this is headed, another interesting example we run into is users are having .1x failures, or users are failing to authenticate. And ultimately, again, I want you to think of what is the human action needs to be to just address this. Don't create all the mumbo jumbo. And we could say, hey, on that Radius server, either that server is unresponsive, or you need to add this AP as Radius client to it. Whatever it is, you can go and you could say, hey, I'm going to assign this to Rob at Mist, and Rob, please take care of this on the Radius config side, whatever it is. So you can actually start to do a full workflow on this, fully integrated with sort of northbound systems, right? But the final frontier of this, where this is headed truly, is I think what Bob is talking about, and sort of tongue-in-cheek with what we were talking about with Lee, is we know problems when they happen in the field. We know software issues, we know hardware issues. This is, I think, a game-changing moment in our industry where we are going to be out there saying, absolutely, if there is a software issue, we're going to basically go correlate that issue. If a process crashes, if a process is lagging, we're going to take that fingerprint back to our cloud, compare it to all the fingerprints that exist there and say, oh yeah, we've seen the software crash. And oh, by the way, I actually have a firmware version that has already addressed it. Right? So now you don't have to be in the business of reading release notes. You don't have to be in the business of saying planning for an upgrade. Again, all of our upgrades, a lot of our customers do upgrades sort of while network is running. We have a fairly intelligent upgrade methodology there. And so you can actually say, in this case, May, like you said, no, don't upgrade my system. Let me think about it, but give me the data. And so you could say, yeah, I'm going to upgrade it now, I'm going to upgrade it later. Or here's a button where actually it's going to say, you know what, do it for me next time, don't ask me. Yeah.
For the really careful admin out there, Is there any kind of way you can add a link to the release notes because they've been burned so bad that they still want to read them?
Absolutely, absolutely. Yeah, no, for sure. And we do have those as well.
Awesome.
So we've been talking about this, approaching it from the infrastructure side for a very good reason, obviously. At what point does Mist take this to the next level? Because we all know that wireless is a very user experience heavy thing that's very subjective and less objective necessarily. At what point do we start ingesting feedback from your users, from the end user devices into the AI engine and validating at a higher level maybe, okay, you said you had weak signal or you had poor performance or we saw high channel utilization. Was the user actually experiencing a problem?
Right. So I think, to that question, next year when we're here, what we're talking about is Marvis ingesting data from different sources. What you're seeing this year is bringing more data in from the wired network. By next year, our goal is to start having the client's view of the network ingesting into Marvis, right?
How
Now,
would you do that? Would you install an application on it?
did I mention about indoor location?
You got it in there.
And indoor location is moving from a nice to have to a must have. So over on this side of the business, we still have this actual client SDK that we do for all our indoor location clients. So our plan is to start to take that client and move it over to the IT side, right? So yes, we have an asset right now where we provide the client's view of the world, right? So I think this is to your question, right? It's moving to more of the client side. Yes, once we add that visibility, we will actually be able to start letting users kind of what we almost do, I call the PG&E thing, yes. If our users want to report a problem, we'll be able to say, yes, we're aware of that problem, Mr. User, and the ETA is X. Or, Mr. User, thank you for reporting it. We've added to the list, and we will get back to you on when the ETA to fix it is. So that's the beginnings of, yes, the vision of, yes, we will start bringing the client view into Marvis.
A follow-on really with the location. When I think about Mist as a company and the customers that are going to go to Mist. Obviously, you guys are playing in some very large environments, but I also think about companies that they don't have IT they don't have a strong wireless person on site, and they see Marvis and what you guys are doing, and they go, this is perfect because I don't have to have that really strong Wi-Fi person. But those are generally also the companies that are going to skimp on proper RF design, right? And when you don't have good RF design, that kind of escalates into all kinds of other issues, and it's really hard to get to the bottom of those unless you deal with that. Are you guys using currently, or is it just roadmap where you're going to use that location analytics to be able to begin saying, this is a problem that can only be solved with adequate RF design? Is that something you guys are trying to return to the user of this to say, this isn't something we can fix in AI. This is a PHY problem.
So I think when you look at the SLE metrics, so there's capacity coverage. So those metrics kind of tell you very quickly if you've designed a terrible network and you've got a bunch of coverage capacity problems. Those show up very quickly right now. So I think that's what's happening today. Yes, we can basically tell customers, yes, you guys, you've got a big coverage capacity problem. I think that's where we're going, right?
Yeah. Right.
I can't solve that. Eventually, guys, you got to go add some more APs here. You got to get your coverage and capacity back up if you want to have good user experience.
But absolutely, actually, exactly what you were saying, right? So I can go to our system, our current service levels, and service levels today is saying, there is some coverage issues and capacity issues, whatever, right? But that particular user who's not super wireless savvy, what does 65% on coverage even mean to me, right? So now that's where I feel Marvis actions, we want to come in and say, you know what? We've determined it. You need to add APs on the 3rd floor in the West Wing. Literally, that is the goal. I think Marvis actions should basically, and which is the whole vision here, is distilling all of this data to what is the one human action. If you think of how we've troubleshot networks for 20 years, right? You start with a problem, user experience, and you go down, you peel the onion. Ultimately, it's a config change, an image upgrade, a software patch, whatever it is. Ultimate human action is what fixes the problem. We want to take that entire journey out. We would like to send people home and have some time with family with Marvis actions, right? I mean, I think if operations starts their day and ends their day with Marvis actions, I think they're better off. That's the whole goal here. Right, and I think, sorry, did that answer the question?
Yeah, I think so, yeah.
So let me just maybe finish around. I think an interesting problem in our space. Really around, thankfully, as an industry, our RMAs are not very high percentages, and we are experiencing something similar, I think. So that's all good. But when a hardware failure happens today, the experience today is something like this, right? So if you take a site or a store or a building, whatever, the user has to experience the failure. Then they call in IT and says, hey, in this particular area, something is amiss. Then IT has to come in and figure out and sort between, is that a compatibility issue? Is it a software issue? Is it a hardware issue? And let's say it is actually a hardware issue. What do? We actually have to remove the existing AP, plug a new AP in and say, hey, the problem actually traveled with the hardware. It didn't travel with the locale, right? So, and then you have the hard job of calling into TAC and saying, convincing level 1, level 2, level 3, that this is an RMA and you deserve an RMA. What we're doing is cutting that entire journey out and saying, hey, you know what? We actually are running continuous health checks on all of our hardware. And if we say one particular hardware is actually sort of catastrophically failing, we're just going to let you know. We're going to basically say, this is an option to say, you know what? Yeah, ship this AP directly to that particular store. Or you could even say, next time don't ask me questions, always ship it to my depot where I stage these things just automatically, right? So this is the impact of sort of AI at work for you. And so this is really where we feel the the culmination of AI is now a lot of these actions could be human-led. We talked about some of the actions that we already intrinsically do, which is when there is a software failure and we can, whack the radio, whack the AP, whack the process, any of that, we do that intrinsically. We don't ask permission. Intrinsic actions we're already taking. We're already in that self-driving mode. But now with the Juniper merger, now can we actually add switch config to it? Now can we actually add via APIs to Infoblocks, add this AP as a radius client or something? To one of the radius servers, right? Or make release IP addresses that are locked up in Infoblocks, right? So all kinds of interesting stuff can happen once the efficacy of these answers is really good. So this is what we are super excited. Hopefully you're excited, but this is sort of the new face of Marvis.